Welcome back. In today's video, we are going to do a new class implementation and see how that works with our existing applications. This is hopefully going to show you another uh, power or flexibility of object-oriented design that lets you take an existing application and extend it with different capabilities. So in a previous video, when we unboxed the new Pico kit that I got, I had told you that there were some new hardware that was in that kit that I did not have in the Pico library. One of them was this RFID reader. So if you recall, I think we talked about it. So this is the RFID reader that comes with the new kit. And it's basically a Prox RFID readers, very similar to it can read NFC 13.5 megahertz tags, and it can even write data into those tags. So this little guy can basically do all of that. Now, we're going to talk about how we are going to incorporate that into our Pico library, add that class to the library. And then what we will do is, if you recall, we had built this garage door opener, which basically used a prox sensor to detect proximity. And then depending on whether a vehicle comes into the door, open the doors. What we will do is we're going to extend the functionality of that garage door openers. So instead of an ultrasonic sensor, we're going to replace that with this RFID reader and show you with object-oriented design, we don't really need to do anything with the logic of the class, just talk about how the model can incorporate this new class instead of what we had before. So that's the plan for today. Let's hope you guys follow along. Let's see what we can find about this reader. So this is an MFRC522. That's the name of the reader. And since we're looking for MicroPython, search for MicroPython. And there's a bunch of lots of information about, but I like to look for GitHub source code that's already available. So here's a device driver library for that reader. And it's got some documentation, but here is essentially how to use this. You're going to create a soft SPI, which is nice. That would allow us to use any pins for our serial peripheral interface. I think in a prior video, we talked about I2C and SPI. There are two different ways the Raspberry Pi Pico can communicate with other devices. So this one is using the software SPI, which is a little slower than hardware SPI, but the nice thing about it is that you can basically use any pin for the SAK, MOSI, and MESO pins. If you're interested on how that works, you can take a look at documentation. But the hardware SPI requires you to use specific pins, and if you see that I'm pretty much out of pins in this implementation, so I'll have to find 4 available pins once we remove that ultrasonic sensor that we can use with this. But you would see that this class is written really as a device driver, not, although it is a class, which is nice. A lot of these device drivers are not even written as classes. They are basically just code that you incorporate. But at least here you see there is a class called MFRC522, and it's got, read, write, set bit mask, clear bit masks, lots of code about calculating CRC. So all of the internal things that this hardware requires for you to be able to read and write from it. Now, while this is great, this is really written as a device driver and not meant to be used as a as a user class. In our object-oriented world, the way we look at it is this guy is an RFID reader. Yeah, we can go into the details saying that it's an MFRC 13.56 Prox reader, etc. But To us, this is just an RFID reader, and what we would like to do with this guy is be able to read from it, be able to write to it, and see if we can do other things like clearing whatever data is in there and so forth. Okay. So that's what we would like to do. So how do we do that in MicroPython? Well, if you recall, what we're going to first do is we're going to create a class. So here's the MFRC522 from, this is basically that same code that I showed you on GitHub. I've copied that already into Tawny here. And then what we're going to do is we're going to create our own class called RFID Reader. Okay. And I have already sort of worked on it, but I don't want to write code on screen. So here is what we would like to do. We'll create an RFID class that is well documented. We're going to import that MFRC 522. We do not want to redesign the driver. This driver is already available. We're going to incorporate that. We're going to make sure all of the GitHub, all the headers that are in there. Nice thing is, if you notice that MFRC 522, it has an MIT license, which means it is free to obtain a copy, as long as I'm going to keep this copyright notice in there. So we're not going to change anything in this driver class, keep it exactly how it is. Simply, we're going to incorporate it into our own class. So what does RFID Reader class have? Well, it's got 4 or 5 buttons that you can connect. In fact, I'm not even gonna use the reset pin, but so that's basically what we're gonna do. The MOSI, MISO, SCK, and SDA, those 4 pins that you see in the back, those are the ones that we will use. And we'll, as usual with other pins, we're gonna add a log message when it's connected. We're going to work on essentially 3 or maybe 4 operations. So our attributes are those hardware, those pins, and then this one, which essentially takes the reader class. Also, these RFID readers do have password capabilities. So if you do want to add a password to your tags, you can actually do that. We're not going to go into the details of it, but at least the default password is basically all ones. That's essentially what the password is. Insecure, but at least that's the default. We know that, so we'll keep that also as an attribute for future use. But there are basically some simple applications like get tag ID. Tag ID is a read-only ID that is given to every tag. So when you purchase one of these MFAIR tags, they come in all kinds of shapes and formats. So this card is the most common. Something like this is also available, and there are a whole bunch of different ones. And you can get the tag ID, and that is a good starting point, that you can essentially use this as the ID for the tag, and you can use that, put that in your database for your users and things like that. Technically, you don't even need anything else once you have the tag ID. But what is kind of cool is you can actually write data and read data from the reader. So you can read something from the reader that's in there, or you can write the data to the reader. So you can actually write something like a name and things like that. And then we can also clear the data. So that would allow us to basically clear out whatever data that has already been written. So essentially, that's all we want to do. And these are all the methods that have been created. So now what I'm going to do is I'm going to show you some tests with this reader, make sure it works properly, and then we're going to incorporate it into our garage door. Okay, so let's test out this class that we have just written. So to make sure that it works properly. So what we're going to first do is we're going to, from RFID reader, import star. And now we're going to create an instance of this reader, just like we have done in every other class. And it takes, as we saw, it takes 4 pins. I actually removed the reset pin. It's not necessary, and sometimes it causes problems. We'll just leave the reset pin. It allows us to reset the reader for, if it stops functioning, but it needs to be connected properly in order for it to work. So we'll just leave that. We don't need it for our implementation. So we created the constructor. So now we have a reader called just called it R. So let's see if we can read something from the reader. So we say get R dot get tag ID, and it returns us none. So nothing was read, of course, because there is nothing in front of the reader. So what I'm going to do is put this tag in front of the reader, and we're going to try that again. And notice that now it returned back with a tag ID. If I put a different type of tag in front, it gives me a different tag ID. So these are the IDs of the tag. They're unique. Every time a tag is manufactured, it's given a unique tag. So, but it is the same tag that will be returned every time you present. So this white thing has this EEC tag, and this blue keychain has the C3C tag. Okay, so now let's see if we can read some internal data from this tag. So remember, we created a method called the read data and write data. So that's different from the tag ID. The tag ID is factory written, and that cannot be changed. So in order to read and write data, you can read to its memory. They usually have like about 1 kilobyte of memory. So there's not a whole lot of memory, but there is a decent amount that you can write to. In our implementation, I actually basically put a max length of 80 characters. So if you try to put more than 80 characters, this is going to give you an error message. But that's just my implementation of it. Because if you try to write more, you have to be careful that not to try to write on reserved areas of the tag. So that goes into the detail we do not want to worry about for this. So what we're going to do is let's try to read what's in here, r dot read data. And it says it's got hello world written to it. So let's try to write something to it. Write data. Let's say we want to write design with Pico. And it says wrote data and was successful, so it returns back a true. So if I read this back now, it should say design with Pico written to it. What is nice about it is this is actually permanently written. Well, not permanently, written into the tag. And this is cool because this runs without requiring any batteries. So this is actually how battery-less Prox tags work. They're powered by the power coming from the reader, which is kind of nice. So if I put it back in and I read it again, we'll see that the design with Pico is still there. So let's see what is in this tag now, this other one. This thing says hello testing. So let's write design with the OO programming. Okay. So notice that if nothing is there, it's going to give me a false. Nothing was detected. But if I put the tag in front, it wrote and it says was successful. So if I read it back now, there you go. So the blue one now says design with OO programming, and the white one now says design with Pico. All right, so that's how simple it is. At least for our implementation, we made it simple, and that's what the object-oriented design lets us do. We can create our own classes and give them their own type of functionality. So the next step would be to now incorporate this into our garage door opener. So I'm going to be doing some changes in wiring, and I'll come back when that is done. All right, so I have connected the RFID reader now to our garage door model. I had to find some pins to use, but the nice thing about the soft SPI, the software SPI, is that I can basically use any available GPIO pin, so I do not have to worry about unplugging things I already had connected. So now I'm basically out of pins, believe me or not. But at least I found four pins that I could use to connect to the RFID reader. So now what we're going to do is see how that changes our model. This is the original garage door model we had, which had the controller connected directly to door, and the door had connections to a motor and a sensor. So what we're going to do is we're going to create an alternate model. So here is the alternative model, which in which I created a subclass of door called secure door. Left the original door class unchanged, and what we're going to do is we're going to add our RFID reader class as an association with secure door. Okay. Gets data, something like that. And we'll make sure that we'll give them like a one-to-one. Each reader connects to only one door and vice versa. Yeah. Okay. And if you remember, the RFID reader has additional attributes and methods, but let's add the methods that RFID reader has. And those are, of course, the init, and it takes those four SDA, SCK, MOSI, and MESO pins. It has a get tag ID. It has a read data, and it has a write data. Those are the attributes, right? So that's essentially what we have. So essentially all we did was create a subclass of secure door and connected that to our RFID reader. Everything else basically stays the same. So let's take a look at the code then. And here's the code. In door, I have imported RFID reader, and I've created a subclass of door called secure door. And all it does is it instantiate the superclass. It needs to with the servo pin and prox pin. We're not sending up the pins that we needed for the ultrasonic sensor. Instead, we're creating an RFID reader. We're creating a method called add reader that would allow the controller to add a reader to the RFID reader. And then all we're doing is we are overriding the vehicle detected method from the superclass, which was using the ultrasonic sensor before. Now it's basically just checking to see if there's a tag at the door. And if there is a tag, we're saying true. Ideally, of course, you are going to have specific tags assigned to specific users and things like that. But for the purpose of this demonstration, keeping it simple, if it detects any tag at all, it's going to allow it. Okay. So now let's see how the controller will change. Of course, the controller is still using the old door class. We have created a secure door class. Now we're going to have to use that one instead of the door class. So we'll say secure door. And of course, the T pin and E pin goes away. And what we will need to do is self.door.add reader. And this is where we add the reader SDA, I think. 13, SCK is 14, MOSI is 15, MISO is 16. I believe that's how I connected it. Well, if it doesn't work, then we will find out if I connected it wrong. And that's basically it. I do not need to change anything else in the code. All we need to do is subclass the original door class, and instead of the original door, we are using the secure door and adding the reader to it. Everything else in the controller stays the same. Now, let's see how this works. Okay, so now we are in the original state, initial state, and obviously the door is closed. And notice that, of course, this thing is now an RFID reader. It's not going to read anything, any procs. I have to present a tag in order to open the door now. So if I present the tag, now notice that the door goes into the open mode and closes. Of course, since any tag should work, I can present this guy as well, and that should work as well. There you go. And that works the same way. So now you see how we can change the functionality using completely different hardware with just a few lines of code because of object-oriented design. And that's essentially the utility of object-oriented design. This is why we are trying to learn object-oriented design, even in the context of a Raspberry Pi Pico, which is such a simple platform. So hope this was useful and you got something out of this, and I will see you in the next video.